The science of exoplanets is a relatively new field. While planets outside the solar system had been long predicted, it wasn't until the early 1990s that the first one was officially confirmed. Since then, we've confirmed close to 5,000 more of them. But that's still but a tiny fraction of the total number of planets we suspect could be out there, which reaches into the trillions. Now, though, as we move through the 21st century, we're not just confirming exoplanets, but we're getting to know them. And we're beginning to understand how rich and varied they can be. In late 2021, the first details emerged of a new breed of planet in the universe. We of course know all about the inner Rockies and the outer gas and ice giants in our own solar system, plus the dwarf planets in the asteroid and Kuiper belts too. But these worlds are orbiting much more distant stars than our Sun, light years away from us, and scientists are only just beginning to explore them. According to a multi-authored study published in the Journal of Geophysical Research, Planets, we so far have at least 3 so-called eggshell worlds to monitor. The study, titled The Effects of Planetary and Stellar Parameters on Brittle Lithospheric Thickness, has thrown light on what's believed to be one of the rarest types of planets out there. An eggshell planet is a rocky celestial body that's in many ways like Earth or Mars, but with one major difference. Its outermost layer is extremely thin. This layer, which consists of the planet's crust and part of its mantle, and is called the lithosphere, is in fact so thin that it cannot support much variation at all. It can't hold up mountains or allow for valleys, for example, and so the worlds themselves are also often described as being extremely and unusually smooth all over. There are so few natural landmarks on them that they're like perfect marbles suspended in space. But let's scale back. Why does the lithosphere matter in the first place? On Earth, it's what we think of whenever we try to map and understand plate tectonics. We know that plate tectonics are crucial to how Earth works, generating new land from old and ensuring that we continue an age-old geological cycle across the planet. But we also know that so many of Earth's most defining features have come about thanks to the movements of the plates in the lithosphere. Incredible mountain ranges cutting through continents, vast canyons entrenched in the land, and seemingly endless underwater ridges that stretch beneath the ocean. The creation of all of those occurs in the lithosphere as a result of plate tectonics. Eggshell planets have a different backstory though, and therefore a different way of working. Their outer layers are thought to be just a few miles thick, although the planets themselves can still be quite large. From what we know so far, their surface temperatures are then thought to be blistering. In this way, these worlds actually might in part resemble at least one of the inner solar system planets, Venus. The surface of Venus is scorching hot too, with lava bubbling away and extreme heat emanating outwards. A major difference, though, is that Venus is home to many a volcano, whereas eggshell worlds probably aren't. But why are scientists so interested in this? Well, eggshell worlds are really just the latest in a long line of exoplanet possibilities, realized by us humans as we peer out into the universe and gather more and more data. In this case, their existence has been theorized after the team behind the 2021 study ran thousands of models of planets and star systems, tweaking key parameters each time. And as with so many other astronomical studies, this one had a couple of key considerations at its heart: potential habitability and potential alien life. What makes a planet habitable, and what conditions are needed on a planet to allow for the emergence of life? Ultimately, at this early stage, it's perhaps difficult to see how eggshell worlds could ever be habitable due to their seeming lack of tectonic activity, which is believed to be a key condition for life to happen. It isn't only the lack of surface movement that's holding these planets back, though. Those blistering temperatures are explained away because it seems that eggshell planets tend to orbit particularly close to their parent star. At least that's the case with the 3 that have been identified so far. So while details are scarce at the moment, perhaps this could mean that they barely ever fall within the prized habitable zones of their star systems. But also, there's some suggestion that eggshell planets are young as well, relatively speaking, compared to the other exoplanets that we know of. Perhaps then there won't even have been time enough for life to emerge on them yet, regardless of the conditions that are present. So if you're hoping for news of extraterrestrial contact or of future homes for humanity, then maybe eggshell worlds aren't really for you. And yet these mysterious places could still become truly significant. In identifying eggshell worlds at all, those behind this study are really pushing toward a new level of exoplanetary analysis. Up until now, the study of exoplanets has mostly focused on just finding them and confirming them. But now we're considering these far-off worlds in detail beyond just the standard statistics like size and distance from home star. This most recent study has essentially computed those basic stats and crunched the numbers to paint a much more specific picture of how these planets actually function. Realizing that there could be so many more planetary types out there beyond the solar system worlds that we know so well. The study lead, Paul Byrne, has further highlighted across various interviews and press releases how we can't directly measure exoplanets right now. We're not generally able to look at anything in detail outside of the solar system because it's usually just too far away. But perhaps with studies like this one, our tactics are changing. Naturally, we know that not every planet is going to be like Earth. But now we're getting a clearer picture of just how different all of those other worlds are from one another. And while we have just 3 eggshell planets to work from at the moment, it's a good bet that there are many more out there. And then, even within the eggshell group, there will of course be many further differences and nuances to discover. So will humans ever be visiting these worlds? Will we ever find ourselves treading on eggshell planets, in a manner of speaking? Considering all we know so far, it seems unlikely. The lack of plate tectonics is the main reason why any possible future version of us would probably give them a miss. Followed by the high surface temperatures, if indeed that is a common feature to all planets of this type. But still, in a hypothetical future time when space travel is easy and humans have spread out across the galaxy, eggshell worlds may yet draw the attention of an interstellar civilization. And for any scientist with even a passing interest in how the lithosphere works and how it dictates how the rest of a planet works, eggshell worlds will always offer something different. In the coming years, in these unfortunate times in the real world when easy space travel sadly isn't possible, we're sure to hear at least a little bit more about them. The hunt for exoplanets in general is certainly on, but we've already moved beyond merely noticing that they're there. And even the other offerings in the solar system, like Mars, Mercury, Jupiter, or Uranus, start to seem a little less alien when we consider them alongside what else there is. We've said it before and we'll say it again, space never fails to surprise. And that's why scientists are studying what have come to be known as eggshell planets.